Welcome to the answers for the electricity revision lesson. I'm going to walk through every single question and I'm going to explain how I would think through the answer, and I'll obviously show you what the answer is as well. So what I'd recommend is, as I do this, pause the video at various times and check your work and see how you did. So let's make a start. Question 1. A current is a flow of charge. The diagram below shows a circuit containing 6 identical lamps. Identical is always important because it means they're the same. Explain why the bulb on path 3 is the brightest bulb. So what do we have? We have a circuit which is in parallel. There are 3 branches, path 1, path 2, path 3. And we know that in a parallel circuit, the potential difference or the voltage is the same across each branch. All right. However, what do we know about these 3 branches? Well, path 1 has 3 bulbs, this has 2, and this has 1. So what do we know about the resistance of each branch? Well, path 1 has 3 bulbs and the highest resistance. We probably actually don't need to say this because we probably could just say that path 3 has only 1 bulb, the lowest resistance. If something has a low resistance, what do we know about the current? Therefore, the current will be the highest. So we've got the same potential difference across each branch. We've got the highest current. One more thing which is probably relevant. I mean, it's only 2 marks, but I'll explain everything I would think about. The potential difference is going to be shared across 3 bulbs here. So imagine this was 6 volts. The first one gets 2, the second one gets 2, etc. Path 2, imagine it was 6 volts. This gets 3, this gets 3. Path 3 gets the entire potential difference. So path 3 has only 1 bulb, so it gets the full potential difference. So what do we know? We know that path 3 has the highest current, highest potential difference across the bulb. Therefore, the most energy will be transferred to the bulb. So path 3 has the highest current and potential difference. So the most energy will be transferred to this bulb. I've probably written slightly too much because I've got 3 points for 2 marks, but better to be safe than sorry. All right, part B. Place an X on the diagram where the current is the greatest in the circuit. Well, we've already said here, if this has the lowest resistance, it must have the highest current. So we'd put an X here, or we'll put an X here. Anywhere on this branch here where there's 1 bulb is fine. Place a Y on the diagram where the current is the least. Well, the current's going to be least where the resistance is the highest. The resistance is highest where there are 3 bulbs. So somewhere on this path 1 between here and here. All right, question 2. A security light is designed to switch on automatically when it becomes dark. Part of the circuit for the security light contains a battery, a light-dependent resistor, and a 2000 ohm resistor. In bright light, the voltage across the 2000 ohm resistor is 4 volts. Calculate the potential difference across the LDR. So this is the LDR here, not the usual symbol. Usually there's a circle, but they've doesn't matter. They've told us what it is, and there's arrows coming in. This is the LDR. So this is 6 volts. If this is 4 volts, what must this be? Well, that should be super easy. 6 volts minus 4 volts equals 2 volts. So the answer is 2 volts. Calculate the current in the 2000 ohm resistor. Show your working and state the unit. So what do we know about current? Well, we know that if we have current, resistance, and potential difference, current times resistance, we know that this is the relationship. So what does that make current equal? So current equals potential difference divided. I'm just going to use the slash to represent divided over resistance. So what does that equal? Potential difference, we were told it's 4 volts. So it's going to be 4 divided by 2000, and that's going to equal 2 times 10 to the minus 3, or 0.002 ohms. Although actually I could probably just copy and paste that symbol for ohms. Sorry, not ohms, it's not, what am I talking about? Current. So yeah, it's amps for current. So this here is the answer. All right, question 3. A student sets up 2 circuits to investigate the difference transformers make to circuits. Compare the 2 circuits, including reasons why the transformers make a difference. Suggest how circuit 1 could be improved to make the bulb glow more brightly. Let's see how many marks it is. 6 marks. We need to write 6 bullet points. But it's okay because it's actually told us 1. This is the first thing it's told us what to do. This is the second thing that it's told us what to do. And this is the third thing that it's told us what to do. So actually we've got 3 mini questions. So it's actually not nearly as scary as you might think. We're okay because we've got 3 2-mark questions. So compare the 2 circuits. In fact, I'm going to do this one last, and I'll explain why in a minute. So why does the transformer make a difference? So circuit 1 is brighter. What does circuit 1 have in it that circuit 2 doesn't? So circuit 1 has a step up and step down transformer, whereas circuit 2 doesn't. Right? Are there any other differences? There's no other differences. There are no other differences. So immediately, I'm already comparing it, aren't I? I'm stating the obvious. This is literally what it says in the question, which may or may not get me marks. But this is also important. There are no other differences. That is a comparison. So why does a transformer make a difference? So what does the transformer do? So a step-up transformer. So they increase the potential difference, voltage, and they decrease the current. So now, what does a decreased current mean? Decreased current means less energy lost due to heating. So remember from the lesson on the national grid, we said that power is I squared R. All right, so this is power loss is I squared R. So if you can reduce the current, you are reducing the power loss. Okay, so and we've already explained that here. All right, so I've explained it and I've given a reason. Now, importantly, in power loss, there is also this thing resistance here. So what I might do in just to make it super clear, in this bullet point here, I might say resistance is the same. Just to make it really clear that the only thing that's changing is current. Therefore, the only thing that affects the power loss or the energy loss is the current. So where are we now? We've said that circuit 1 has less energy lost. So the step down transformer decreases the potential difference and increases the current, returning the voltage back to the 12-volt input. So what I've done here, I've just basically explained that we've obviously made the potential difference higher here. So it might be, 24 volts, but then we need this step down transformer to make it back to 12 volts so the lamp works normally. So we've pretty much got an answer now, haven't we? 1, 2, 3, 4, 5. We've got 5. This is probably actually worth 2. This first bullet point probably isn't worth anything. So what I will do, I'll just put one more bullet point in. So the bulb in circuit 1 glows more brightly because there is less energy lost in the circuit. I might actually, I always write a little bit too much in these questions, but it's a good thing. I might just write the resistance of circuit 2 will decrease the current. But this doesn't happen in circuit 1 because of the transformers. All right. So I'm pretty sure this will get 6 marks. So you can pause the video now and check it through. All right. Question 4. Washing machines have an outer case made of metal. The picture shows the earth wire connected to the outer casing. The live wire becomes loose and touches the outer casing. Explain why this does not give you an electric shock. So the earth wire completes the circuit between the live wire metal case and ground, or back to the mains power. Therefore, the electricity goes through the earth wire instead of you. And then why does it go through the earth wire instead of you? Well, the earth wire has a lower resistance than a person. All right. So making it bold to make it really clear. The electricity always goes down the easiest path. So if it has a choice between going down a low resistance earth wire and you, it's going to choose to go down the earth wire. Now, obviously, if you touch this with wet hands, you increase the chance of getting an electric shock because you are decreasing your resistance. So you'd always want to get this fixed, but hopefully the earth has saved you if there's a fault that you don't know about. All right, part B. The earth wire is thicker than the live wire and the neutral wire. All right, so why is the earth wire thicker? So this is for safety, to make sure it can carry a larger current than necessary in case of a fault. All right, so obviously thicker wires can carry more current. Also, in fact, I don't actually think this is the main reason. I've just realized now. What else is really important? A larger wire with a larger cross-sectional area has a lower resistance thin wire. So this makes an even lower resistance path. It's kind of two reasons. One is that a earth wire has a lower resistance than a normal wire, so it's going to make it even more likely that the electricity goes through that than you. But also, to some extent, because it's thicker, it can also carry more current. So if there was a fault and loads of current came through it for whatever reason, it's also going to stop it getting hot and its resistance increasing and kind of melting or something. But this is the one that I would write for 1 mark. All right, question 5. Let's just get it all on one page. This question is about current and static electricity. Zara has a vacuum cleaner. Its power rating of 1200 watts, connected to the 230 mains. Calculate the current to the vacuum cleaner when it is switched on. Give your answer to 2 significant figures. It's amazing how many people forget to do this, and this is always a mark. You just get a mark for doing this. So we've got power and we've got voltage. What equation relates power and voltage? Well, it's current times by potential difference. So power is IV. We want the current, so current equals, in fact, I'm going to do it this way. I'm going to do 1200 watts, which is the power, is equal to the current times by the voltage. Right. So now, how do we get this missing number? Well, obviously we do 1200 divided by 230. Which is 5.217 blah blah blah, but we want it to 2 significant figures, so that's 5.2 amps. Okay, 2 significant figures. So this is what I'm going to write down on the answer line. Right, you should write all this working out. Part B. Fuses are available in these values. Which fuse should be fitted to the vacuum cleaner? Well, the current is 5.2 amps, so we want the fuse that is the next largest fuse. So which of these is the next largest fuse? Well, it's the 10 amps. This is the next smallest, or the next next smallest fuse. Okay, because it needs to be bigger than this so it doesn't melt, but we don't want it too big that it could be dangerously hot. All right, 6. Look at the 2 circuits containing identical bulbs. The bulb in circuit E is bright, the bulb in circuit F are equally dim. Explain why. Use ideas about current and resistance. This is very similar to question 1. Circuit F has a higher resistance and a lower current, so bulbs will have less current going through them and be dimmer in F. All right, so this comes up all the time, every single year. Higher resistance, lower current, or the opposite. So if you write this down, you've got a very good chance of getting a mark in these kinds of questions. All right. This question is about circuits. Chloe connects this circuit. She investigates the relationship between current and voltage for different wires connected between A and B. Look at her results. Calculate the resistance of wire Z. So what do we have? We have resistance, current, and voltage. So we know that resistance is voltage divided by current. So we need for Z, we need the voltage 8 divided by current 0.5, which is going to be 16 ohms. Super easy. Part B, which 2 of these statements could explain the results for the resistance of the wires? Wire X is the same thickness but longer than W. So what is the result? This is important. What are these results that it's talking about? and it's talking about X and Y. So Y has more resistance than X. Oops. So YX is longer. Oh, sorry. We need both, don't we? W and Y are the same. X is the least resistance. So X is the same thickness but longer than Y, than W. This is quite confusing, this question, actually. Right. YX is the same length but thicker than W. Oh, right. Okay. I think there's been a mistake here. This is actually one of the statements. I've understood why it's confusing now. This should be statement A. This is B, C, and D. Okay, that makes more sense. So there's actually 4 statements. So which 2 of these are true? So is YX the same thickness but longer than Y? So that would mean that X has a higher resistance than Y. That's obviously not true. So we can delete that one. YX is the same length but thicker than Y. That would mean that YX has less resistance. So that could be true. YY is the same length but thicker than W. Well, that can't be true because they would have different resistance, but which means that this is the only one that can be left. Okay, so these are the 2 that are true. Question 8. The current in a 12 ohm resistor is 9 amps. How much charge flows in 2 minutes? So it's asking us for charge. What equations do you know with charge? And the first one that comes to mind is current times time. Right, in symbols, Q equals IT. So now we've got time, current, charge, which is great. Do we need this resistance? Actually, we don't. It's trying to confuse us, so we may as well just delete that. So now we can work out our charge. So current times time, so that's 9 amps times by time. We don't want it in minutes, do we? We want it in seconds. So how do we convert to seconds? We times it by 60. Type all that in our calculator and we get 1080, which is C. Question 9. Let's get it all on one page. The filament in a lamp heats up when electric current passes through it. The graph shows how the current changes with potential difference for this type of lamp. Which row has the correct statement about this type of lamp? So it's a lamp. We know, we don't even need to look at the table. We know the resistance increases with a lamp. So it can only be C or D when we look at the table. And then is it directly proportional or not? Well, directly proportional means straight line through the origin. This is not a straight line through the origin. So the only possible answer is D. 10. A circuit contains an unknown component X and the ammeter has a reading of 1 amp. The connections to the component are reversed and the ammeter reading changes to 0 amps. So that's a big clue, isn't it? I don't even need to read the question. I think I know what it's asking me. If you reverse something and there's 0 current, that's immediately the sign that it's a diode. So actually, don't even need to really think about this question much further. This must be a diode because a diode only allows electricity to flow in one direction. 11. At room temperature, the current in a thermistor resistance is 1,000 ohms, is 2 milliamps. Calculate the power dissipated in the thermistor. So when it says power dissipated in the thermistor, it means like the power across or the power of the thermistor. So what do we know about power? Well, power is current times voltage. And we also know it's current squared times resistance. Okay. So which one of these is more useful to use? Well, do we know what the thermistor's resistance is? No. No, we do. No, we don't. We don't know what the potential difference is, but we do know what the current is and we do know what the resistance is. So we need to use this equation here. So the current is 2 milliamps times by 1,000 ohms. What mistake have I made? It should be 2 milliamps squared. Silly Mr. Simon. Now, there's another trick here. 2 milliamps, what does that mean? That means we need to divide by 1,000. Because milli means a thousandth, just like there are 1,000 millimeters in a meter. So we need to divide by 1,000. So now if we type this in our calculator, we get 0.004 watts. So a couple of little tricks there, but it is worth 3 marks. What is the resistance of the fixed resistor in the circuit diagram? So what's the resistance of this? Well, we know what the potential difference is of the circuit. We know what the current in the circuit is, and we know what the resistance of this is here. So what we can do is we can say that the total resistance is the total voltage divided by the total current, because we know that resistance is V over I. So the total voltage is 5 volts. The total current is 0.02 amps, which is 2,500. But we know that the thermistor has a resistance of 1,000 ohms. So 2,500 minus 1,000 equals 1,500 ohms for the fixed resistor. So there's 2 steps. You have to work out the total resistance, take away the resistance of the thermistor, which again is why you get 3 marks. All right, part C. The thermistor is cooled in ice water. Explain how this changes the reading on the voltmeter. Let's just quickly check where the voltmeter is. Right, the voltmeter is not across the thermistor because they're trying to trick you here. So what happens? So as the temperature decreases, the resistance of the thermistor increases. Right, this should always be the first thing you write down in one of these questions, or the opposite. All right. So what happens if its resistance increases? So the potential difference across the thermistor increases, right? Because more resistance, more potential difference. So the voltmeter must decrease. Let's say reading because it's better grammar. All right, let's just quickly explain why. If this potential difference is going up, right, we've got 5 in total and this is going up, what must happen? This must go down. All right, security light is designed to switch on automatically when it becomes dark. Oh, we did this question. This is a duplicate of the previous one. We're going to skip over this one. 13. Dave has a lot of spare time on his hands during lockdown and uses some wire in a circuit. 100 centimeter length of this wire has a resistance of 5 ohms. What length of wire is needed to make a 2 ohm resistor? So 100 centimeters equals 5 ohms, but we haven't got 100 centimeters. We've got less than that, and we have 2 ohms. So what equals 2 ohms? Hopefully you can see this is a ratio thing. We've got 2/5, all right, of the length. because you've got 2/5 of the resistance. All right, so 2/5 times by 100 equals 40 centimeters. Just a simple ratio problem. 14, get it all on one page. Charles is investigating electrical circuits. Look at the 4 diagrams. Electric charge flows around each circuit. The lamps in each circuit are identical. Which circuit is the flow of charge greater? So flow of charge is another word for current. So which circuit has the greatest current? In other words, which circuit has the least resistance? Well, it's obviously A. A is the only one it can be. That's pretty obvious why it has to be A. All right, this has got 2 bulbs, but this has only got 1 bulb. This has got a resistor, this hasn't, so it must be A. 15, in which circuit would a current flow? So this symbol here is a diode. Diodes only allow electricity to go in one direction. They only allow it to go the way the arrow is pointing, so up in this case. Electricity always flows from positive to negative. So which is the positive side of the battery? It's the long one here. So electricity is flowing this way. And, it can go around the arrow. So it's A. They've been nice to us here. It can't be B because electricity would flow this way and get stopped by the line. It can't be C because these batteries here are negative to negative. So the batteries will cancel out. And indeed, the batteries here will cancel out as well. So they won't flow. Okay, final question. An electron is accelerated through a potential difference of 12,000 volts. The charge on an electron is 1.6 times 10 to the minus 19 coulombs. Calculate the energy transferred to the electron. Now, they've tried to confuse you here by kind of talking, about a situation that you might not have looked at, but all you need to remember is this basic formula, which comes from the definition of potential difference. Potential difference is the work done per charge, or energy transferred per charge. So if you rearrange, you've got energy transfer is charge times potential difference. They've given you something in standard form, but you all know how to use standard form. So let's type it into our calculator, and we get this answer here for B. So well done for completing all these questions. If you manage to get a good mark in this, you will do very well in the test.